Hello guys, am I audible? Okay, so good evening guys. Sorry there was some miscommunication today. So welcome to day 6 of Tactile Machine Learning, and my name is Ravi Rana and I'm a mentor. So today we'll be doing classification, and before that we'll cover our linear regression concepts. Okay, so shall we begin? Okay, so just let me share my screen with is my screen is visible? Okay, so yes, let's start. What So how would it work is that today you will all be receiving mails for those who will be filling the feedback form today. Those who will be filling the feedback and the attendance form today would receive a mail, and in the mail there will be the details of the projects that you guys have to undertake. So what projects will be there? So there will be a linear regression project. You have to do all of those things that we have shown in the class: the linear regression, the feature analysis, feature engineering, feature selection. Okay, you can make a project on linear regression, or we will be covering classification in the next 2 days. You can make a classification based project, and you guys will be receiving mail by today or by the end of our session. So we have talked, and if the syllabus that we have oriented for that we have targeted for this whole drill is not completed by tomorrow, what we'll do, we will extend it, we will give it a further day. So after that you will be receiving a mail so you can be receiving a mail for today, tomorrow, day after tomorrow. So please don't spam the Discord channel about it. Please don't spam the chat about it. When we are going to receive the mail, you will receive the mail in due time. And bear in mind, please remember to fill today's attendance come feedback form, because those who will be filling that will only be getting the mail for details of the project, that what projects you have to do. Okay, so for project, what you will be getting 1 week, and 1 week or a little more than 1 week. Say you can get 1 week, 7 days to 10 days for completing the project, and along with the project in the Google form that you will be getting, to submit your project, there would also be some questions. There could be, I am just contemplating the possibilities for that. There could be some questions, and you have to write your own understanding, because we have covered a lot of theoretical concepts in our past 7 days, and we have learned many things. So I just want to know if you guys are comfortable. If you guys are comfortable with theory now, okay. So there might be some 2 to 3 questions, and you have to write their answer in your own language, not a blatant copy paste from the internet. Okay. So this is about the project. If everything is clear, we can start with our feature selection and linear regression model. Okay. So now let's begin. That now we have seen yesterday. We have seen this. We have completed our feature analysis. We covered our features engineering, and I will not be touching those again today. If you have any doubt in that, you can rewatch the videos. You can rewatch the recordings, and we were stuck in a selection. We had a bug in our feature selection part, and I have resolved that issue. So just let me quickly complete that part. Let me just quickly complete that feature selection part, and then we'll be making a linear regression model. I'll be explaining to the linear regression model, and then we'll be jump on to classification. So now we are starting. So is my screen visible to all of you? Okay, so now I have uploaded my dataset, and I have loaded my dataset to this Colab environment, and I have shown all of you how to upload your dataset in the Colab environment. And now, as usual, our first step what we'll do, we will import all our libraries. So now, after importing libraries, we will be making a data set, and we will be making a data frame, and we will be loading our data set into that data frame. Now, let's just analyze the head of the data set, and this is the head of the data set. This is the whole data set that we have loaded. This is our training data set, and it contains sales price, it contains all the features. So now let's just extract our sales price into a different data frame. I've told you why we are extracting sales price, because we do not want to consider the sales price. We do not want to consider our target variable as our independent feature. It is a dependent feature. So we are extracting in a new data frame called y underscore train. Okay. So now, after extracting that, what we'll do, from our training data set, we will drop our ID and sales price. Why ID? Because we do not want 1480 points for 1480 meaningless values, and sales price because we are not considering sales price, because it is a target variable, it is a dependent variable. So now here I've explained it to you yesterday that we will be using lasso regression for feature by minimizing the slope, and we will be using select from model to select the important features. So I have covered it yesterday in depth. So now just a quick revision. What is our alpha? Alpha is our variable. Alpha is our variable value. Alpha is the lambda value that we have seen in our theory sessions, and random state is the degree of random state. So we will be initializing our lasso model with an alpha value of 0.005, because as I've told you, the alpha values lies between 0 and 1, and the degree of randomness is 0. So now we will be initializing our select from model. Now we will be initializing that our selection object, that on what basis we are selecting this objects, on what basis we are selecting the features. So for that, we will be using select from model and lasso regression as our underlying basis. Okay. So why we need to minimize the value of alpha? Because as I've stated here, that the bigger the value of alpha, the less number of features will. So now we will be fitting our training data into this object that we have made to select the important features. So for that, we will be using the fit function, and we will be using the xtrain and ytrain function. Okay. So now just run it. And this has given us that we have initialized our select from model on our training data set. Now what we'll do, we are getting a function, we are using a function on our object for feature selection, is that we are using get support method. So what does this method do? This method give us the important values. This method gives us the important features that we need to select. So here important features are marked as true, and the unimportant features are marked as false. So okay, so get support is pretty simple. So now we will be initializing a value. We will be initializing a list data frame where we are storing all the columns from our data set. We will be making a list where we are storing all the columns in our data set from our data set, which are important for building these models, and we'll call that list as selected features. So now let's print how many numbers of features are present in this selected features. So how many total features we had initially? We had 82 initial features, and from this, how many features were selected? From this, 21 features were selected, and what coefficient shrank to 0. So what is the meaning of coefficient shrinking to 0? If a feature is not important, we say that its coefficient shrank to 0. That is not of any importance to us. So these are the total features, these are the selected features, and these are the features that we do not require. So out of 82 features that we had initially, only 21 were important, and we will be building our model according to that. Okay. So now let's see what are the selected features. These 21 features are our selected feature. Now let's append our data set. So now earlier our data set contained all of those 82 features, but now will be only using these 21 features. So let's save those features only and remove the rest. So what we will do, we will be overwriting our data set extreme with the selected features only. So we have done that. So now let's analyze these features. And what do you get? These 21 features are only the important features. So am I clear till now? I have explained it again. I explained it yesterday, so it might be clear to all of you. Okay. So now let's concatenate. So yesterday I told you that in our data set we need a target value. Okay, we need a target value. We have selected the important values initially, but we need the target value. We need the dependent feature. So what I'm going to do, I'm going to concatenate my selected value. I'm going to concatenate my target feature. My target feature here is the sales price with the data set. So what is concatenating? Adding two data sets together. So yesterday, what problem we were having it that the sale price were pointing to NAN, that the sales price was giving NAN values. So what problem did we encounter? So what problem was that is that it was that the concatenation was happening row wise. So what is row wise concatenation is when the two data set try to concatenate in this row measure manner, but I needed the column measure manner. So what did I do? I initialized the axis is equal to 1, and this reset index is used because we do not need any index values. These values are just present because these because these values just initialize the number in your collaboratories environment. These values just give the numbers in your collaboratory environment. Okay, so now we are concatenating our both those two data set, and what we see is that sales price is concatenated with this data set. So now let's just save this data set. I will be saving this data set as using the same function that I've used in feature engineering, that data to CSV, and I'll be naming as data CSV, and the index would be false. So now let's run this. So now our change will be reflected here in our content library. Just as you can see, we have a new file that is called data.csv. Okay, so is feature selection part clear? So now let's build the linear regression model. So this is the notebook for linear regression. Let me share the link with all of you so that you can see it with me. Okay, so linear regression is the most simple part here. The preparing data for linear regression was the most toughest. So let's do that. Let's make our data. Let's do linear regression. So as usual, first of all, let's upload the data set to the collaboratory environment. So for that, I'll be using this. And this data, I've not downloaded it earlier, so I'll be opening this. And now my data is uploaded. Okay. So now let's first of all, what we are doing is that first, as usual, we will be importing NumPy and Pandas. NumPy for numerical Python, NumPy standard for numerical Python, and is for complex mathematical functions, and Pandas for loading the data frame data set as a data frame. And I'll be reading the data set using read CSV function, and I'll be analyzing this whole of the data set, that what features are we getting. Okay, so the data set is now loaded. So now let's make two two different data frames from this data set. The first data frames contains our x values. X values stands here, the features. Okay, the number of features that are present, the number of features. So let's store all of those features in a single data frame, and let's make another data set y that contains the target values. Okay, so for that we have a function called ilog. Ilog is just is a sort of function that we use for slicing in the data frames. So what does this notation means? That I am including every function, that I am including every value, every feature from starting to the end. Just I'm just not including the last feature. I'm just not including the last feature because in from last I have this sale price. In the last I have this sale price. So this denotes is that from I've included everything from starting, but just not the last one, the -1. Okay, the -1 index. -1 index is the last index. I'm not including this. So here what I'm doing, we had 21 features that were important. So what I'm doing here is that I'm including everything till the 21st feature. So from here to here, I'm discarding everything, but just, and I'll be using this feature only. I'll be using sale price only. Okay, so now after doing that, let's analyze our y dot head. So in our y, we only have our target values or the sales price. So am I clear with the initialization of x and y? X contains all our features and y contains the target value. Please, yes or no? Okay, so now what we are going to do, we are using a function that is present in sklearn, a function that is present in the sklearn library that is called train test split. So what happens in real world, we have a lot of data, we have a large amount of data, and for that we do not have files that we do not have files that originally split the data into the test set and the training set. So for that, we used a train test split. So in common machine learning practices, what do? We use the training data set and the test data set. Our machine learning model trains on the training data set and the testing takes place on the test data set. Am I right? Yes. So now what happens is that in the training data set, when we have a single data set and you need to extract the training data set and the test data set from that data set only, we will use a function that is called train test split. So now for train test split, what we will do, we will initialize four variables, four tuples, four list, as you can say, that x train, x test, y train, and y test. So this x train and x test would give us the training features and the testing features, and y train and y test will give us our training value, training dependent values, and y test will give us our testing dependent values. And for that, we will be importing train test split from sklearn.model selection. And now we will be using our function train test split. We will be giving our independent features x as a parameter, our dependent feature y as a parameter, and we are going to make a test size 0.3. So why 0.3? So see, our data in common machine learning practices, what we will do, we will split our training and testing data in a ratio of 70:30. So 70% of data goes for training purposes and 30% of data goes for testing purposes. So now test size gives us 0.3. So 30%, if we multiply it by 100, it would give you 30. So test size is 30. So test data size is 30%, and random state again is the degree of randomness, that how randomly those data points are selected. If you set the random states at 0, what will happen, that starting 70% will go to the training data set, and the rest 30% would go to testing data set. So that might give rise to bias. So but now what does random state give you? Random state select random 70% data and random 30% for testing and random 70% for training. Okay, so are we clear with train test split? Please. Okay, so now we have split a data set into training and training and testing part. So now what we are going to do, we just need to import our linear regression model. So as we have seen our linear regression day one, that from sklearn.linear model we will import linear regression, and our reg is our object that will be initialized as the linear regression object. And now we will be fitting our data set. We will be fitting our data set that regression is working on X train and Y train. Okay, so from sklearn, we will sklearn linear model. We will be importing linear regression. We will be initializing it to an object called reg, and we will fit X train and Y train on it. So now, what does fitting mean here? Fitting mean training. The data set will undergo training. So now our data set, our model has been trained. So now let's just check its accuracy. So by predict, so let's check reg.predict. So we have our testing data set. Why we will use? So why we are using the predict function here? What is the use of the predict function? So predict is used for, we have our testing data set, and on our testing data set we know our initial values. For in X test we have Y test. We have that for these parameters we have this answer. So we will be checking how our model is performing. So we will initialize our object. We will initialize Y predict as regression.predict reg.predict on X test. We will be running our model. We will be fitting a straight line to our X test, and now we have predicted, and it has all the values that our machine learning model have predicted is stored in Y predict. And now from sklearn.matrices we will import R2 score and accuracy score. So we have talked about R2 score and accuracy score. So now we will not be using accuracy score here. Accuracy score is only be used in classification, and we will see it through practical implementation. So now let us evaluate our model, and we will be using a variable score as R2 score. We will be using our Y test, that the original values, what are the original values and what are the predicted values. So now what our R2 score is? Our R2 score is 0.89, and I have told you, if our R2 score is close to 1, if our R2 score is close to 1, our machine learning model is performing very well. Okay, so now is linear regression clear? So now one doubt, if all the dividing of the data into train and test are fixed, or it varies according to a problem. So it is a common practice to divide the data in 70-30 ratio. You can also be using 80-20 ratio, but 70-30 is more prevalent. Okay, so any other doubt in linear regression? And shall we jump on to classification? Okay, so let me add some water, and we'll be jumping on to classification of our today's lecture. Yes, Mukul. Yeah, it is right that if we are getting more accuracy, that if we are getting an accuracy level astonishingly well, so it is overfitting. So I have told what is overfitting is. So what is happening is that our machine learning model is working very well on the testing data set, or the training data set, testing and the training data set, but it is not working in the real-time scenario very well. So it might be a case when if you are getting an accuracy of 98%, that your machine learning model is overfitting. So general rule of thumb is that we try to set the accuracy values in the range of 90 to 95. I try to set the values of the models. I make the accuracy values in the range of 90 to 95. So if you are up to a challenge, if you are up to a task, what can you do is that go on, download the dataset, download this house price dataset. Do not do any feature analysis, do not do any feature engineering, do not do any feature scaling, and just implement it straight away through a linear regression model and calculate your R2 score and see the difference between those two R2 scores. Okay, so now just let's start with today's topic, that is classification. Let's start with classification. Is my screen for classification is visible? Okay. So now, what is classification? So it might be quite clear to you that what is classification that we are talking about. Yeah. Yes or no? That what is classification? It's just a simple term that you just classify these two items into two different classes. Grouping is a sort of clustering. Classification is you classify, you identify the objects in two different classes. So now let's get back to our example of predicting the images of cats and dogs. So now our machine learning model is trained on images of labeled images. Labeled, I'm saying labeled. Please pay attention to it. So now I am giving labeled images of cats and dogs. Right? A machine learning model knows that this image is of cat, this image is of dog. So now it trains on it that if an image looks like this is an image of a cat. If the image looks like this, it is an image of a dog. So now what you will do is you will train the machine learning model on that. So now this machine learning model would classify, now you provide it with a new image. So now our machine learning model would classify that image as image 1 as the image of a cat or image of a dog. Okay, so this is classification. We make different classes. Here our class was the cat and the dog, and our machine learning model try to evaluate this new data into the previously defined classes. So am I clear what classification is? So what are the types of classification? First of all, we have binary classification. It's just simple that when we have only two classes present, like our example here, that we had only our model could only predict with the difference between a cat and a dog, so that an image can only be of a cat and or of a dog. So we had two classes to predict with for prediction. So this was binary classification. So now what is multi-class classification? So multi-class classification is somewhat advanced form of this classification. So in multi-class classification is that we have more than one class. We have more than one class. In binary classification, we had more than one. We had two. It was defined that we had two classes. So in multi-class observation, we have more than one class. Okay. So now what is multi-label classification? Multi-label classification is similar to multi-class classification. Okay. In multi-label classification, we have multi-label classification, we have more than two classes. Okay. We have more than two classes, just as in our multi-class classification. So here the dependent variable has more than two categories, and just as we have talked about this in multi-class classification. So it is different from multi-label is different from multi-class classification is that an observation can be mapped into more than one category. An observation can be mapped into more than one category. Okay, so can anyone tell me what does this line means? Anyone? The difference between multi-label versus multi-class classification. So let me tell you, in multi-label classification, is that the classes in which we are classifying our object, the classes in which we are classifying the object are somewhat related. So in multi-label, the classes can be somewhat related. Okay, so this is a difference between multi-label and multi-class classification. So are we clear with these three types of classification? Okay. So now we have many types of classification algorithms. So no, I didn't got it. Okay. So difference between multi-label and multi-class. So let me just think of an example. Okay, so we have a data set. So for example, let's, for the sake of multi-label classification, there is a famous example. It's called Leptograspus crabs data set. Let me just show you. Type it in the command box. Leptograspus crabs data set. So what is this Leptograspus crab? The Leptograspus crab is a type of crab which contain of different colors, which is of different colors. Okay, so it can be either blue or orange. So, and that we need to classify between a male and a female crab. So here you can approach this problem as a multi-class problem. That you can make this problem into, divide this problem into 4 classes. That is, that the crab can be a male and it can be blue. It can be female and it can be blue. It can be male but it is orange, and it can be female but it is orange. So now we have made 4 classes. So now what is happening in multi-label? How you can approach this problem as a multi-label classification? You can divide this whole problem into just male and female. You can just divide this whole problem into the male crabs and the female crabs. Okay, so this is the difference between multi-class and multi-label classification. So now am I clear with what is the difference between multi-class and multi-label classification? Am I clear? Please yes or no. Okay, so Mukul has written that under beverages there are juice, milk, and many more. This may be referred to as multi-label classification, and multi-class classification can be like food and beverages. So now here you can say that your multi-label can be food and beverages. Your multi-class can be these different sort of beverages, that different sort of drinks that are beverages, but your multi-label would contain just food and beverages. Yes, you are right. So now let's dive ahead. So what are the types of classification algorithms? What are the classification algorithms? So we have many sort of classification algorithms. there are most these five kinds of classification algorithm. Logistic regression. So you might be thinking it has regression under it. Its name contains regression. Okay, so how you can use it in classification? Regression is used for prediction. Regression is used for prediction. So why are we using it for classification? So, but this is this is a different case of regression. Logistic regression is used for classification. So for logistic regression, you will find many tutorials over the internet, many tutorials that have covered logistic regression in depth. So we will not be proceeding with logistic regression. We will only be covering k nearest neighbor. We will be talking about k nearest neighbor, its mathematical approach, its and how we can implement it practically. And the other other three famous classification models are support vector machines, naive Bayes, and ensemble classifier. You can note it down, search about it, read how these differ from each other. So okay, so now proceeding with k nearest neighbor. So we have heard a phrase that is called birds of a feather flock together. Okay, so in KNN, k nearest neighbor, it is assumed that a if a data point is close to a data point that belongs to a defined class, this will be that data point would be belonging into that class only. So suppose we have a data set that contains images of a cat and a dog, and you add a new point, you add a new image, and that image is of a cat. So our KNN assume that our new added image would be closer to the all of the images of the cats in the data set. So if the initial idea clear for k nearest neighbor? Is the initial idea clear for k nearest neighbor? Okay, so let me tell you one more interesting thing about k nearest neighbor algorithm, that you can also use this algorithm for regression. You can also use KNL algorithm for the purposes of regression. So now let's analyze this. Now let's take a look at this picture. Our KNN assume that in this data set, this color is present. All the point that belongs to this color are close to each other. All the point that belong to this color are close to each other. So now is birds of the same feather flock together? Is it now painting a clear picture in your mind at how KNN is, what is the assumption of KNN? Just a simple yes or no, please. So now it's maths time. Let's see the mathematical intuition of KNN algorithm. Okay. So first of all, let me know that is it clear? Is it what KNN is clear? So now we will be seeing the mathematical intuition behind KNN. So first of all, is my board visible? Okay, so let's see now. Let me may take a two-dimensional data set or a binary data set, and let me just make it here. Okay, so now we have two different type of data: x's and circles. Okay, so these two type of data are present in their own area. So x's are present here and the circles are present here. Okay, so now we have a point. Let denote it as triangle for now. We do not know for which class it belongs. It belongs to one of these two class. Let consider this point and denote as with the triangle. Okay, so this point So how KNN is working is that it sees that it compares the distance between these 2 points. So now we can see that it these three x's are in close proximity to this triangle than these two circles or these three circles. Okay, so now this distance is less and this distance is more. So now it will classify that our triangle is actually an X. So are we now clear is that how KNN is initially working? So now to analyze, these values, to analyze this algorithm, let's go into more depth. Let's in No, it is not going to measure the distance with each point. So just let me uh, further enunciate my point. So now, is if any one of you having a this doubt that why we used KNN, why we use the term K nearest neighbor? Nearest neighbor, we are clear that it is nearest to the axis, so it might be a X. So why we are using the term K here? Anyone thought of it? Okay, number of points. Okay, number of points. So what number of points? Number of points from this, number of points from that, number of points is a variable. Okay, so what is the use of these number of points? So just let me tell you, before initializing this KNN, before initializing the KNN algorithm, you need to define a value of K. You need to define the value of K. Okay, so what is the value of K is that it will check that how many points, that if it will check for K number of nearest points. So suppose here we initialize the value of K is equal to 3. So it checked for 3 points, for the distance of 3 different points from this. So it checked for the different distance of three distant points. Because our K here was initialized to 3. If it was initialized to 5, we would be initialized for 5. Okay. Okay. So now am I clear with the concept of K? What K here in use? We have two groups for so 3 points from each. Yes, if for in binary classification we have three groups, we have two groups here, so it will check from 3 points for each of this. Okay, and it will check if 3 is present in both of them only. So suppose it is further distance from this zeros, it is further distance from the circle. So suppose it is present, it is not present here, it is not present here, but it is present here. So these 3 points of these three axes are in close proximity from this, and we say that only two circles are accessible from here. So this triangle belongs to X. Okay, so if 3 points, if three nearest neighbors are present near this point, okay, this is the use of a K. This is how a K nearest neighbor algorithm works. Okay, so for now, how is the distance calculated? How the distance is calculated? Let's so to calculate the distance, calculate the distance from these point, we use two type of distances. Two types. First one, Euclidean And the second one, Manhattan. So Meet have just correctly answered my question that distance is calculated as Euclidean and Manhattan. So Meet, can you tell me that where we use Euclidean and where do you in what is the most common use? Don't tell me where, but tell me which type of distance is most commonly used. Yes, exactly. Euclidean is used most commonly. Euclidean is the most commonly used distance calculation in the problem. So where do we use the Manhattan distance? If for a multi-label problem, I guess in a multi-label problem, there in a multi-class problem, we can use Manhattan distance. Manhattan can give us slightly better results. So for most purposes, Euclidean distance is used. So now, what is the Euclidean distance and what is Manhattan distance? Okay. So now we have these two. For this, I'm using Euclidean. I will be explaining here. Manhattan, I will be explaining here. Okay. So we have two coordinates. X1, Y1, and here X2, Y2. When the distance is calculated directly, okay, when the distance is calculated as x2 minus x1 whole square plus y2 minus y1 whole square. So this is called a Euclid. This is the formula of Euclidean distance. When distance is calculated directly, it is called a Euclidean distance. So we have all studied about Euclidean distance in throughout in our high school mathematics and most of our engineering courses. So is Euclidean distance clear? Okay, so now talking about Manhattan distance, we have 2 points. And y2. Here, the distance will not be calculated like this. The distance would be calculated is like this. So the sum of these two distances is called Manhattan distance. So what is Manhattan distance? Is clear that what is Manhattan distance? Okay. So now let's just see the formula for Manhattan distance. The formula for Manhattan distance is mod of x1 minus x2 plus mod of y1 minus y2. Okay, is the formula for Manhattan distance is clear? Okay. So now let's just see what are the problems in this KNN algorithm, because not everything is hunky dory. We have some problems everywhere. So what is the problem with this KNN algorithm? Is that if there are more data points of one class, suppose the X contains more data points than the O's. The X contains more data set than the more data point than the O's, which means the data set is imbalanced. So now when the data set is imbalanced, what problem does it gives us? What problem does it give us? Please, we have been talking about that from past 3 to 4 days. What is the problem that it gives us? Let me give you a hint. It starts with B. Can anyone tell me if there are more data points for certain variable than the other variable than the second variable? Yes, yes. Thank you, Vaishnav. The answer is bias. It will the data set our model would be biased toward X, and our triangle might be predicted as an X. Okay, so one problem of this one problem of this KNN algorithm is that it does not work. It does not work well with. It does not work well with these variables, these imbalanced data set. So now the other problem. So suppose we have outliers. So what is an outlier? We have seen about outliers. That what is an outlier? Is an outlier is a value that lies very far away. So see, we have a classification problem. So in classification, every point are grouped together because a point can either be a 0 or a 1. So suppose we have in our data set, we have our classes is that we have x's and we have circles. So now suppose we have a triangle and there are certain outlier values of x. Okay, we have these outliers value of x. So now the distance between x is less than distance between the circles. So now our triangle would be predicted as an x because of the outliers. Okay, so is the effect of outliers clear? Yes or no, please? So now let's jump back into our slides. So we have seen what is k nearest neighbors. We have seen these problems regarding to k and n. So now some pros and cons that in which situation these we use k and n and in which situations we do not use k and n's. So pros, this is very easy to understand and easy to implement algorithm. Okay, it is really simple and you do not need to build a model. Just tune some parameters and you're good to go. And this algorithm is versatile. This versatile means that it can be used for classification, regression, and for searching purposes. Okay, now talking about the cons. What are the cons? So if our database set is imbalanced, as we have seen, if it contains imbalanced values, it will be generating bias and our model will be not performing optimally. And in outlier values, our model would be impacted. So now what are the cons is that the algorithms is, and another problem with this algorithm is that the problem in this algorithm is significantly slower and compared to different classification algorithm. So are we clear with KNNs? Are we clear with what KNN is, what problem KNNs give us? Okay. So for today, I will be concluding the class here only. I will be concluding the class on the pros and cons for this, pros and cons of the KNN. So today, what we have seen the feature. We have completed our feature selection. We have made our linear regression model. We saw about classification. We studied about different types of classification, and we studied about KNN algorithms and how it is used. What is the intuition behind that algorithm, and what are the pros and cons of these algorithms. So are we clear for today? So talking about tomorrow's agenda, what will be tomorrow's agenda? So first of all, we will be seeing the different matrices, different parameters which through the use of which we evaluate our classification model. Just as for this linear regression, we had RMSC, the MSC, R2 scores, and we have several parameters for classification models also. So thank you guys for attending. If you have any doubt, you can ask. Otherwise, you can leave the session. Thank you.